Um, so what are the potential collaborative partners in this building in the SDM? As you can see, local government higher county are really a cornerstone of the largest section here in the community. That's where data is created and managed, right? Our regional partners, academic and nonprofits, it's kind of who's who. This is just a example of it, not limited to these. We want to include anybody and everybody needs regional collaboration for creating and maintaining data for. So what are we doing towards this end? Well, we're starting to think GOD stands for Geospatial Information Data Exchange. So you'll notice that it's missing the U, right? Well, we're missing U. Right? To do this, and we thought, a great response, I think, part of us to touch people who live in this Cuyahoga County. Well, this does everything. Think of anything that you do in Cuyahoga County, most times it actually involves an address. With that. So that's what we're starting is with addressing. So we're working with partners to create and manage spatial data. Interestingly enough, addresses are responsible to municipalities. They are the authorities as it relates to addresses, which is kind of unique because, and I'll get to this a little bit on, but what's really unique about it is Cuyahoga County, we have municipalities. All the other 87 counties have townships, and the counties are responsible for the address of the townships. They don't have any areas. So that's kind of what we're decided. So what we're going to do with this money, we like to create a cash cloud instance and using Azure Enterprise Installation as being the gold standard GIS. Standardizing Azure address data model. We're going to do software and training, we're going to do workflows, access to GIS professionals to actually help assist the municipalities with this type of work. It actually is really a point of what's called the next generation 911 call routing, and that's why we're starting there. Right? It's critically important to life-saving measures, but it's so critically important that it needs to be managed right? And that's a point-based address, not addresses set parcels, right? So every place there's an address, you will see it. We also have to combine that with accurate ESN or emergency service numbering, so that when the call actually gets generated, it hits what's called designating. It actually resolves and tells the dispatch unit where the call's coming from and how to route to it, and all the digital information that goes with that. But it's important to note that addressing has more than just public safety aspect to it. It is the highest and best use from an accuracy standpoint, but a lot of other benefits, a lot of people want to think about. So what is an address? What we know is a number, street, prefix, or suffix, city, state, and etc. Right? But addresses are location based, and they're also mailing based. So think about a PO box. That's mailing. That's not based on location. We want to do location address. It's the XY of where the address actually sits. That's why it's a point-based address. Again, each municipality has its own address. That's why base Cuyahoga is we don't have townships that makes the county very address. So what are the benefits? Right? Well, this is just package delivery, right? We UPS, Amazon, you don't have an address, probably. Utilities, all of water, electric, sewer, anything like that, or not sewer, cable, hook up, and they ask us. That's the address of your location, right? Boards of elections, school, census bureau, right? Census, everybody knows the census wants to have address. The problem is, the census takes those addresses in the state, it's a PI issue there. We will have another issue, right? So that address in takes you where you keep going. That's why it's important. Right? The one thing I find very interesting is the third income tax distribution. We actually have an issue with the taxes actually being sent to the city of the zip. Well, did you know that there are actually only 22 city zip codes within Cuyahoga County, 59 municipalities? The city of Portland does not have its own postal district. It's not listed as Portland. Actually, it's the post office. So if you're going to send the real taxes, right? Based on the district, you send Cleveland. Well, Cleveland would love to have this tax, but they were actually supposed to be broken. So that's why that location. We are not the first. We won't be the last. We are modeling this after very well established systems. Working in partnership is one very mature. It's up in the area of Toronto. And then the National Capital Region Use Station, the exchange is set up. You can imagine the partnerships in very politically charged area like in the state with municipalities, counties, and cities. There's just it's a hot pot, right? Well, they actually did this come together around take build this national strategy or this vision strategy. And so if you ask any municipality or any county leader, they want their citizens to be safe and economically prosperous, you're going to give everyone to say yes, absolutely. So if we could build this infrastructure to help support that, that's what we want to do. Finally, remember how I said cadastral? Well, we're going to start with avenues. The cadastral is something that is a responsibility I cannot say that you would very well at all. So we're actually going through, we're going to do this process through. So we're going to plan out the steps that we need to be successful. We are responsible for recording records within the government. Our conveyance standards have been updated from technology standpoints in 1996. There's a lot has changed in location technology. There's currently 3 departments that are involved in this. The fiscal office, the public affairs office, and the IT departments, and many departments. This communication between them. So much challenges to figure out ways to make that Cuyahoga County's well, this is the cabinet, this is the team right here. This cabinet team experts in the field are going to come through and do this plan to improve our efficiency, increase our accuracy, remove redundancy. We actually keep to data sets right now for what is I don't know if we figure that out. And then introductions of automation. We can automate to take time out of the gap that we want to do. And that plan is estimated delivery in 2022. This is my name and contact information. We actually did launch a brand new website. And that QR code. So if you want to know anything about what we're doing, keep pace with what we're looking to do this this is the place you're going to find it. We're also going to be launching a brand new website for the workforce guide. And that's going to that whole structure to be put together. Go to this website and you will know when you're finished with that and you're on to start putting this out. Hopefully you guys can think about it as it shows as everybody knows. It's people, process, and technology. The technology is the people process. People wants to work and work the process that helps with this. If you have any questions, we got 4 minutes. So if you have questions, anybody has? Yes, sir.
So we did wait days like we need money back.
Yes. Okay. Well, I think you want to do gain elevation in the process. Okay. So part of the data model is XY, but we guess our data to fill the information model. We're looking at now 3D-dimensionally. Just probably start with that one, but triangulation is one that say what comes from cell phone reading and actually do that. the ground elevation to the elevation.
Is that data the public as a whole or that?
Well, I'm not sure what initially, but I'm sure. And if it's being managed by the county, probably
Is there time period for that, or do you want record backwards to find out what who owns property?
well, that's part of that land records improvement process. What we're going to be moving to is called parcel pattern. Parcel pattern does allow data in all the things. One projects we want to know the past 5 years is the facts of all the activities. So, and then all digitized, so you get a quick income and you get the flat, we have a slide and what series of flat series was actually that process.
So from the emergency response, right? A scenario that we actually would be involved in was a 10K run through Cuyahoga Valley. They will have on they asked as well, are you going to set your right? We were on the trail. Yeah. Is there anything that is very
Absolutely. So one of the biggest issues is product side. We actually have buildings, and a lot of them have, right, a lot of facilities that don't have those things. Even if doesn't have you know, we call and we that all we're going to say one home every day. So part of the process of doing an iris evaluation, or what's called rehabs, making iris, billions of iris and billions of there's also a number of places in the leader, let's say log lines, right? So each log line has an address. You make that phone call, trying to get it, and of course that address is where you are. There are some of the technology where it actually resolved there's your GPS on your cell phone. It is activated. Right now, it's resolved. I know exactly what you speak of. I actually know it. Okay. I had some problem building. Okay. So I had to call somebody very quickly to go and find out the address. Seconds and after this section. The county decision. Yes, that's that's time to get ahead and I got birthday. In the presentation, we'll take it.
Well, next up is Tim Hoolihan. Okay, thanks.
Yep.
Yeah.
All right, and knock on wood, they should be able to hear.
Whenever you're ready, just start the timer.
Where's that? Oh. All right. So we'll see if they, if let me know if you get any more questions for that. Yeah, so I did a version of this talk for the Cleveland Art User Group. I talked to Doug. We thought it'd be a good idea to come out here and do that. That link will be at the end, but that talk was 1 hour and 5 minutes. Doug's got me on a 20-minute kitchen timer, so I'm going to talk fast and get through the slide part pretty quick here. So I'm Tim Hoolihan. I'm the organizer of the Cleveland Art User Group. I'm also the data and analytics practice lead for Centric Consulting Cleveland. So really means Northeast Ohio. So we're a consulting company, and obviously, my group's area is focused on data and analytics projects. Primary tools are SQL, R, Python, Power BI. For me personally, I used to be a software developer, so I know a bunch of other archaic languages. But Doug mentioned friend of the show. This is my 3rd time speaking, so I'm just putting in the plug now. When I hit 5, Doug, I want a jacket like the SNL crew. But think about that. Give us some thought. So large language models. I'm assuming everybody in this room is reasonably familiar. But just I'm going to hit on kind of 2 points because that will sort of help us with what we're doing. And so one is I worked for a company that worked with transcriptions of phone calls. And so with deep learning, and around the time we were doing this, language models were really taking off. BERT, if you've heard of it, these are helpful encodings for a language, and we use those on top of transcriptions. But around the same time too, and like recurrent neural networks are being seen as good for this and other things because of the concept of attention. So we won't get into that. We won't have time for 20 minutes, but basically just understand that it's a type of machine learning model, a concept that really helps with this concept of what's next in sequential type of things. And so when you think about generating text, there's not just, well, what do I want to say, but given how I started, how do I want to finish the content? That kind of thing. The other one is, this is my favorite visual. So Benj Edwards is a writer at Ars Technica and just a general tech person. But I really love this when people are talking about large language models. And it's to understand that ChatGPT is trying to create a complete document. And so you see the red box for this is the prompt. So then it's saying, okay, if I'm going to create that as a conversation, the prompt and the response, what does that look like? Then you ask another question, and now it's creating the blue black. So it's and it goes further and further and further. So each time it's including the initial parts of the conversation, right? And so when you think of it as document generation and not Skynet, it begins to make more sense, right? It also helps you if you just think of memory size, and when people talk about hallucination, at some point, it's reaching the bound where it's not giving the model the beginning of the conversation. So the examples you hear, you tell it, I want to talk back to me only in iambic pentameter, right? It's going to start speaking to you in iambic pentameter. At some point, it just forgets that and starts giving you regular answers, and that's because it loses the top of that. So both those concepts make sense. Great. So probably just because the timing of this, we'll do ChatGPT. I also have Bard fired up, so we can do either one. And so Doug talked about being up here. You always have backseat drivers for coding. That's actually your jobs today. So you're free to chime in. We're just going to ask questions of ChatGPT to deal with a code problem, see how it does. And if you want to do it differently, let me know. And my quick example of that is like with the R group, we did a longer Kaggle problem. I was going to go cell by cell and sort of say, load up the file and then let's apply data types. And I appreciate somebody was like, just give it the whole problem, see what it does with it. And then we kind of refine from there. So that's where we'll go. All right. So we're just going to bring up a browser here. I've got a clean ChatGPT window. So anybody ever get asked to do FizzBuzz in a programming interview. See a couple hands going up. So let's just start simple. So chat. Yeah. Yeah, for everybody who didn't hear you said that's when you get up and leave. Um, I'm going to interview you for a Python job. Give me Fizz, Buzz, and Python 3. All right, so if we want to verify that, right then. So I've got this up in case we do a Kaggle, but we can just run that as isolated code. Of course, the Docker container spun down because I've been off too long. Yes, good call. I'll get rid of that. How's that in the back? Better? We got a little more. So I'm spinning it up. FizzBuzz is just, you iterate through. Oh, it's of course it's doing it with one way. It takes standard in. So, all right. So it takes a number, goes to that number, iterating through, and then if it's divisible evenly by 3, says fizz, 5 buzz, or both FizzBuzz. So it passed. ChatGPT's got a job. We're all out of jobs. I'm sorry. All right, so let's give it one more, a little more complicated. Didn't seem here tonight, but I liked Aaron Montgomery's talk here previously on probability. Let's give it Monty Hall. So he and I had some follow-up chat on that. So can you demonstrate while switching or why switching? Switching strategy for Monty Hall. All right, what's chewing on that is it everybody knows what the Monty Hall problem is. This is the classic. You have 3 doors, you pick one. Monty opens one and then says, do you want to stay with yours or switch? And so this messed with mathematicians for a long time, that switching is the best strategy. All right, ChatGPT's yammering with a bunch of explanation I didn't ask for, but that's all right. So give it a new cell here, and we'll run this. So basically did a series of iterated through, simulated the situations, and demonstrated that the winning percentage if you switch is about 2/3. And the or exactly 2/3, just floating points not showing it correctly. All right, by show of hands, you want to jump into like a Kaggle problem, or does anybody have an algorithm type problem? You want to test it first? By show of hands, you can just shout something out. All right, no one's feeling boisterous. We'll look at the Kaggle. So this is the housing price problem. And we'll see how it does. This is when it gets a little more, this is what we found, at least with the R user group, was that the size of the problems began to increase the interesting complex issues that it runs into. CSV of using data with features that we need to be. All right, it's kind of just giving me the first cell, not the whole thing, but that's fine, we'll walk it through that. So I'm gonna delete some cells here, get rid of our hello examples. Of course, anybody who's worked on a Kaggle problem knows this isn't going to work, um, but that's the fun of it. Let's just skip the top of it. Okay, so it's figured out, it knows the wrong path. So I'm not going to give it the path. I'm going to say, write me some code to find the path of CSVs available. You're interested? Oh, so it's not printing anything because it's not finding it. It doesn't even have the right directory. So I'm going to stick by my rule. I'm not allowed to, the rules of this, I went through that slide quick, is I'm not allowed to type any code. Like we have to tell it. So we'll say correct directory is that input Kaggle or Kaggle input? / Kaggle. Okay. Yeah. All right, so a little better. Sorry, this typing angle is really weird for highlighting stuff. The file is this. Load that and show correlations with the price. Typo on that, but you can figure it out. It's an AI. All right, let's see what we get. So interesting. It knew enough about this problem to know that sale price. So that's always interesting because it means that this document was around before whatever the ChatGPT date is, right? And it was familiar enough. But right away, we're seeing here overall quality, ground living area. We get the top most correlated features, right? So let's do this. Let's give it that list. Issue. In that a model that code that includes that file in builds Discussion model with any feature. Greater than percent correlation. Hey, it didn't screw up the path this time. Thank you. Yeah, that's pretty. 1.5. Model is pretty terrible. See this. It always apologizes, whether it's wrong or not. It's just giving me a how-to. There we go. Just need to do some feature engineering. Yeah. So let's look at the model and see if it's doing anything really stupid. Sorry, there was a question over there. What kind of optimization? Sorry. All right, so let's try that again. But optimize the model. You're saying using Fibonacci. Was there a suggestion? What prompt do you want to type? Oh, sure. Again. Yeah. It's a different feature selection criteria. Yeah, just because of timing being short, I want to stick on the same problem, but we'll see if we can get it a little bit of improvement. All right, so we'll do that. Interesting. Yeah, and it actually talked about, so that's interesting. Yeah, we haven't like encoded anything or done any transformation on features. So we can either go after the error or we can suggest that. Let's just because let's try something. Let's try build a boosted tree model instead. Sometimes those are a little more tolerant for input without doing some of the cleanup. Start of the choice. Once again, it's apologizing. Yeah. So just while I'm talking, I'll show the other suggestion was you just want to calculate a Fibonacci sequence or What's that? Value. I mean, I suspect this like is an isolated one. We'll be all right, but
I have a question. It's 2000 Python, you do that in another language.
yeah. So just to wrap the, I mean, the kind of the point of this was just to show, like, it's a generally trained model. So the stuff that it's trained on is going to be, is, you know, if it's a more popular language, there's more documents out there for completion, right? But this isn't a narrow model like the, you know, GitHub's Copilot is much more narrowly trained on specifically code problems. So really, if you want to do this kind of thing, you need to start to look into that. So it's kind of fun, and it debunks some of the like, this is taking over your jobs tomorrow, right? A lot of the stuff that we gave it back in there was intelligently responding because we know a little bit about machine learning to say, well, you try feature engineering, try transforming those kind of things. I'll just quickly flash the slide so it gets in the recording that, and I'll share these through the meetup, but that last link, this has like an hour and 5-minute drawn out version of this where we go through NR for anybody who wants to see. So, thank you very much.
Well, next up is Mark.
Yep.
It's evening.
Evelyn, you. Here we go. I'm sorry. Oh, okay. Assuming this one, the screen. There we go. 1 second. What about blocks everything there? Let's see. That's better. Thanks. Yep. Okay, I think we're good. I hope everybody can hear me. What? Okay. All right. All right, I'm Mark Gapp, and I'm founder of the Great Lakes Data Watershed. And to give you a little background on that, it all started about the time I stopped wanting to travel every day for consulting work and travel the West Coast and Europe and stuff. And I participated in the Great Lakes in a 2019 area hack that was sponsored by the Cleveland Water Alliance. And what I realized, and I think it's still the case, hasn't improved at all, I think, is that Great Lakes data is very difficult to access. And, you know, we talked to, there's a lot of it out there, but it's very difficult to get a hold of. It's of minimal value. And I was surprised how bad it was, having been, and I'll tell you my background in a minute. It also enables inequity. So the fact that it's hard to get at means that maybe a few scientists, if they work really hard, can get it, but can citizen groups or individuals or citizens or students get at it for their benefit? The answer is no. There's also been a lot of talk. Has anybody heard about the Smart Lake Initiative?
Yeah.
All right, there's a lot of talk about the Smart Lake Initiative, but our data is not smart. All right, there's very little data that's accessible. People are putting in more buoys and sensors, but the data situation has not improved. So my background, I'll go through this really quickly. I was a chemistry teacher in Bay High School many years ago. I then turned to writing software for analytical instruments and did a lot of did a laboratory information management system. Then I decided to go for the money, which was in technical computing. I worked for a couple of Silicon Valley companies in product management for integration systems and business decision systems and that kind of thing. So when I got tired of traveling, I looked into the idea that I think there's a lot of ideas that I had that I thought we could apply to the problems associated with dealing with our data problems for environmental data. And it's really a passion. So something we had prior to that is I developed a platform with some others to do visual processing that was able to handle very large amounts of data. Now, it's not based on big data technology. It's based on more of a horizontal kind of scaling. But the system has an architecture called an event watershed, which really manages that real well. So it's a distributed system for managing data. And we applied it originally as system management and application management. So what did we do? You know, we really wanted to tackle this idea of getting access to data. And I think we've been remarkably successful since 2019. So these are just some of the sources of data that we integrate into our Great Lakes Data Watershed. I just have an intern that's working for me now, and he's integrating, he's got all the vessel data from the Great Lakes coming in, which isn't exactly environmental, but it's fun to see the vessels coming in or the vessels coming in to drop buoys in the water, see the buoys in the water and the data they have. Northeast Ohio Regional Sewer District uses some of the instruments here, so we have all their data. USGS, we have all their data. NBBC, Seagull, which is the biggest independent group or a funded group doing Great Lakes data. We're kind of partners with them and we have their data. So we have many sources of data. And it's easily accessed by citizens and scientists. It's available from these important existing sources. It's really easy to add new data sources. So I used to work in integration and building connector things, and we have that built in our platform to be able to build things that connect to stuff very easily. We've added 3 sources in the last month. All the data we have can be aggregated. So what I'd say is we're unlocking the data, the value of the data for the Great Lakes. And if you plug this URL in, you're going to see over 1,000 sources of data from USGS, NDBC, And the URL is data.gledw.org, DW2 API retrieve latest events. There's over 130 different individual sources that are coming in every hour to 10 minutes, maybe, depending on the source. Now, we didn't want to stop there. We wanted to do something with the data. So we built a set of components to instantly build dashboards for data. So we have all these dashboards available. Some you might recognize as Doan's Creek data, information on the Cuyahoga, USGS salinity data for the Great Lakes area. And what we like to say is that we're now enabling citizens and students who could build these dashboards to now have access to data they never had access before. Now, what are we doing in 2023? Well, we've kind of taken the idea of, well, we have these neat tools for gathering data. And, before I do that, I think I'm going to look at our screen. It's always dangerous to do that, but because I would like you to go to our website sometime. See if I have enough time. Oh, I'm doing it. Okay, it's 14 minutes. Huh? Am I talking too fast? Or? Huh? Okay, so here's this is our map, and there's really the sources on the left are all the 10 different sources we have. This is live data from NDBC, including their buoys and their the buoys and the weather stations. We have Northeast Ohio Regional Sewer District data. I'm hitting it too many times because I'm. Okay, here's all the USGS data. So there's over 400 stations. And it's all here. We have a link to the USGS site from there. So to give you an idea, we have a lot of data here. We look at some other dashboards we have. For example, let's go look at Ohio watersheds. So the nice thing about this is you can list all, I did that twice. I did that. If you take, if you fix that, bless you. These are all stations, and these are the two different major watersheds in Ohio, and this describes them. And these are live things. You can drag this timeline and go back in time to see previous times, and compare them. One thing that's kind of interesting is you can go and decide, which of these rivers got to flow first. So you can go back in time and look at it. So actually our responsiveness is really good. We're going back in time for the whole screen, and these also. I'll show you one more. We're doing some work with the metro parks. And this is all the data that is collected in the metro parks area, including volunteer data, which is marked with a dark thing, and you can pull all that up. We can go to their watershed stewardship center and find out about, what's going on here. This is live data by their weather station from the watershed stewardship center. And then going a step further, there's an outline of it. These are the stations that are there. We can go look at the I better do the green roof here. Well, this is their working wetlands area, and this is a live picture, and this is the weather data at the same time. And what's kind of cool is we can go back to the winter, and this is winter, even though the photograph is way down there. We go back in time and see what the wetlands was like on that day, including the weather. So these are sun pattern, this is a pattern of sun intensity and related to the temperature. So we have kind of almost the ability to go back in time and look at data as it existed 2 years ago, integrated with visual data. Going back to the slides. So what we decided in 2023 is we wanted, I think we have the cool stuff out there. I think we had the best collection of data for the Great Lakes. I think we have the most powerful ability to build dashboards. The technology is really interesting. I'd love to dig into it with all of you. We're using Mongo database, Java, JavaScript, HTML front ends, messaging, our own messaging framework, our own architecture, our own kind of GIS information system that we designed. So, but basically what we want to do is go from kind of having dashboards to having an experience. So I don't know about you, but I played Pokemon Go too much, and I realized, what keeps me hooked with it. And it's kind of having a sense of place and experience, some collaboration, the ability to do data quests. So this is our big announcement today, is that starting next month, we're going to be starting having online data quests that are very similar to what you'd see in a challenge in Pokemon Go. So you go and you log in, you become a member, and then you can go and go hunt for challenge items. And it kind of combines a virtual team research tool, because this is serious data, this is serious stuff, with a multiplayer game. Educators people are calling this gamification. And I think that's an important educational and scientific movement. So here's a little sampling of our kind of newest screen. This is what we're working on for August. So this is basically a challenge. And we're saying, okay, you can come in and you're going to start a data quest. There'll be like about 30 of these. And then they go and find that data. So they have to go back in time to different geographic areas, and there'll be a little kind of a compass showing them which way they have to go to find it. And this is all kind of close to working. This is our development system. And we're going to have experts to help them. In this case, the data analyst might look at data patterns. Now, we're not talking about AI type stuff right away. We're talking about stuff. I was an analytical chemist, so I know if this is twice that, there's something wrong with that. So they're very simple rules. So initially, we're going to implement very simple rules that give feedback, like an expert system would, and then we could go to using both machine learned kind of experts too. So that feature will be slightly introduced in August, and we'll kind of continue to build on it. So these are our two data quests for August and September. And people can sign up just by registering on our site. And then in October, we're hoping, don't look at this slide yet, we're hoping to combine with Cleveland Data Days to have a Cleveland focused data quest that's about different sources of data from Cleveland, like the Metro Parks, like Northeast Ohio Regional Sewer District. So where are we going? Who are we and where are we going? Well, this has been a labor of love. It's not about the money, but we are looking at supporting this platform for other users, for other nonprofits and stuff. And we have one potential customer, which is one of the bigger ones, and other nonprofits that do this kind of stuff. And they're interested in kind of the components we're offering that allow us to manage a great data watershed and at the same time do quests with it. So our focus is to move down and no longer manage all this, but provide components to other nonprofits. And that's pretty much it. I have a few minutes for questions. Yes. Yes. So that's a really good question, because like when you go to USGS, we can get data from any time in the past. Well, currently, we're only dealing with the data that we've been collecting for the last 3 years. Now, we are looking at writing bidirectional gateways with those data sources, so it can be a true data hub that can go back in time and get it fresh from them. But right now, we're hosting those. By the way, we have, over 60, I know it's not big for the big data people, but, we have 60 gigs of data with over 40 million data sets, multi-point data sets. And you notice the performance of screens perform really well. I didn't get the whole question. No, we don't have a lot of water quality data from down there. We have all the USGS water quality data, but I didn't notice that any of it that we had. And most of what we have USGS data from all over the United States. So, but we don't, and we have all the water quality data access, but just configuring it to know which ones to get is sometimes a little challenging. Yeah. We don't, it can't be used from the web on the mobile app. And we will look at, we'll say we'll go visit the Metro Parks Watershed Stewardship Center to learn that thing, right? And so we are going to have location, but right now it's mostly based on them finding data in the past and seeing patterns and being able to say that fits that criteria for a solution. Yeah.
I feel like kind of made a very big exclusion. Like going for some sparsely resources like the Southwest. We thought like through potential customers for maybe for the students.
Oh, yeah. One thing we're looking at is part of the school systems that are different places in the future data. And we don't have some gigantic, ambition as far as the commercial model. We just want to have people more going on. But the basic, everybody that's doing this is not doing this as well. So, and I go to the conferences, and so it's really one of our customers is one of the big players in terms of confidential about it, because we have data they don't have, and we possibly quite a bit of money to source it. So, we're looking at different models for making money, supporting them. But to just take a good example, that Scott Research in Pennsylvania, right there's a whole Chesapeake grant. We're doing this for very little. We'll do it for that for our cost plus. That's it. That's how we're doing it.
That wasn't necessary.
Oh, yeah, we're talking to people, we're talking to people like most organizations in the mountain.
And again, sorry for the audio problems in the first session for the folks online. And again, want to thank everybody for coming. Another huge round of applause for John, Carol. So, yeah, the facility here is fantastic, and most importantly, they paid for the pizza. So that's, yeah, goes without saying. So thank you again. So thanks everybody, and.